Good morning, guys. So this is MS Reddy. So assistant professor, Department of ACE, Vignan Institute of Technology and Science. So in this video lecture, we'll discuss about the 8086 microprocessor memory segmentation. So this is just this is a slide for the memory segmentation of 8086. So basically, 8086 memory segmentation will be divided before going to that memory segmentation of 8086. So what is memory segmentation and what are the types of segmentations? We'll go for that in this slide. So basically, if we are going for memory segmentation, segmentation is nothing but what? So we are dividing that memory into different parts. So that is a memory segmentation. So if we are going for general addressings of the memory, so there are two types of the memory organizations or the memory addressings. So that is linear addressing and the segmented addressing. So linear addressing is nothing but total memory will be used by the user. We are taking only one memory and that memory we are taking it for the programmer. So that is a linear addressing. So if you are going for segmented addressing, so in this, so the total memory of that device will be divided into different parts. So that parts we are taking it for the user and as well as for predefined purpose. So that is linear addressing and the segmented addressing. So generally we won't go for linear addressing in 8086 microprocessor. We will go for only segmented addressing. So now in that segmented addressing, so memory space will be divided into the different chunks, that is different parts. So that we are calling it as a segment, and this memory segmentation we are taking it for 8086. So linear addressing we are not going for 8086, that will be there in a 8085. In if you are going for 8086, basically we are going for memory segmentation. So in 8086 memory we'll have totally 1 MB memory is there. So that will be available, that memory is available with the help of your 20-bit address bus. That is, so in 8086 microprocessor will have 20-bit address bus. So with the help of that, we can have the 2 power 20 combinations. That 2 power 20 combinations are nothing but 2 power 20 is 2 power 10 is 2 power 10 into 2 power 10. 2 power 10 you can take it as 1k, that is 1024, and 2 power 10 is again 1k. 1k into 1k, so that is 1 MB. So totally in 8086 microprocessor, so we will have 1 MB of space, external memory. 1 MB of external memory is there. So that is the 1 MB external memory supported by 8086 microprocessor. But if you are going for 8086 microprocessor memory, the total 1 MB memory is divided into different chunks. That chunk we are calling it as a logical segment, and each and every segment will consist of 64 kilobytes of memory. So and if you are going for segmented memory of 8086, so basically we'll have data segment and extra segment and stack segment and the code segments, and these segments will be available by the programmer. This is nothing but these segments can be used by the programmer. Not only these segments, you will have some other segments. Those segments will use it for different purposes, that is for the manufacturing purpose, for the storage of general purpose, for the general storage, for the general storage we will use that memory. So if you are going for the memory segmentations of 8086, so basically we'll take the code segmentation and the data segmentation and extra segmentation and the stack segmentation. So each and every segment will take 64 kilobytes of memory. So totally 4 into 64, 256 kilobytes of memory will take for these segments, and rest of the memory will be taken by other segments. So this is the segmented memory what you are taking in 8086 microprocessor. If you are going for physical organization of memory or physical memory of 8086, this is the total 1 MB memory what you are taking, and these shaded parts are your data segment and the code segment and the stack segment and the extra segment. So and rest of the memory, see, apart from the shaded segment you will have some other segments also, and these segments you use it for manufacturing purpose, or some for predefined interrupts, some for other things, all for other applications we can use it for this. And you'll have some different IOs are there, so for that IOs also we can use this memory, or for the general storage also you can use this. So this is the total physical memory of 8086. So basically, see, if you are going for the shaded parts, so these are our code segment, data segment and extra segment and the stack segment. And in this, so this let us go for this first one. This is a data segment memory, and for this the data segment initial address is that 20,000H and ending address is 24FH. And these are, see, this is only some example diagram what I am taking for the physical address, but depends on the values what you are taking in the segment registers, depends on the values what you are taking in the segment registers, depends on that these values will be depend, that is the starting address, and that ending address of the segment memory will be depend, right? So this is a data segment. For the data segment accessing, we will use the data segment register, and the corresponding register, corresponding offset register is source index register, that is data segment register and source segment for source index register. These are the two registers what you are using to access this data segment. And this is what, this is your code segment memory. So this, in this code segment memory, starting address is 3480H and ending address is 4489FH. And this is a code segment. In order to access the code segment, we will use the code segment register and instruction pointer register, that is offset register what you are using for this code segment memory. And depends on the values what you are taking in the code segment. In the code segment, depends on that these starting and ending address will be depend. And similarly you can go for the stack segment. This is the stack segment memory, and for this stack segment the initial address is 50,000H and ending address is 54FH. And here, in order to access the stack segment, we will use the register as stack segment memory and offset register is stock pointer register. And with the help of these two registers, we are going to access this stack segment memory. And this is your extra segment. This is not stack segment, but in this diagram I have represented that as a stack segment, but that is not stack segment. This is the extra segment memory. And this extra segment memory also, the status as what we have taken for these segments. Similarly, I am going to take this starting address as 70,000H and ending address as 74FH. And this is the extra segment. And in order to access this extra segment memory, we will use the segment register as ES, that is extra segment register, and DI, that is the destination index register. In order to access this memory, we will use these two registers. And depends on the values what you are taking in the segment registers, depends on this, depends on that the segment memory locations also will change. This is the total physical memory of 8086. This is a 1 MB memory organization, right? So if you are going for physical address calculation, okay, how, see, generally whatever the registers you are taking in 8086, so all those are of 16 bits, but this physical memory size is 20 bit, right? Now how we are going to convert that 16 bit address into 20 bit address, that we are using, that we are taking in the generation of 20 bit address topic. So in this slide, so how the 20 bit address will be generated, so all those things will be indicated here, right? So as I have indicated previously, so all the registers what you are using in 8086 are 16 bit, but you have to convert that 16 bit address into 20 bit address with the help of this generation of 20 bit address, right? And if you want to go for the physical address, obviously what I have explained in that diagram, so if you want to go for the physical address, that is the segmented memories, so you have to use that segment register and as well as offset register. So if you are going for a code segment, so that segment register what you are using for the code segment memory is code segment register, and the offset register for that is instruction pointer. And if you are going for the data segment register, data segment is, that is data segment memory, the segment register what you are using for the data segment memory is the data segment register, and offset register is BP. So in this case you can use either BP or SI, that is source index register. So here if you are going for SS, that is stack segment is a memory. If you are going for stack segment memory, for that we are going to use the register as stack segment register as stack segment register, and the offset register as stack pointing register, stock pointer register, right? So not only these three, we'll have one more segment register, that is extra segment register. Extra segment that is extra segment memory. Extra segment memory is the extension of the data segment memory. We are calling it as extra segment memory. So in order to access that extra segment memory, we will use the segment register as ES, and the corresponding offset register is DI. That is, these are the two registers what you are using to access those segmented memories. These are the two registers what you are using to access that segmented memories. That is, if you are going for code segment, that is CSIP, data segment DSSI, and stack segment SSSP, and extra segment ESDL. So these are the registers what you are using to access those memories, right? So now I'll take one example here. Now in order to calculate that code segment memory physical address, so I am going to take that is CS and as well as IP. That is, so if you want to go for the physical address calculation, we are going to take physical address calculation of code segment memory. We have to take these two, right? So if you are going for generally, if you are going for physical address calculations, we will follow the four steps. One is first find out the segment register and the corresponding offset register what we are using for that segment memory. This is the first step what you have to do, and the second step, we should take the segment register value and shift that value by 4 times towards left, or we have to multiply that segment register value by 10. That is the second step what you are taking. And the third step, so that multiply whatever we have taken that above step, that is for the second step, whatever you have taken the second step, to that step you have to add that offset address. These are the three steps what you have to take in order to get your physical memory. In the fourth step, so if you are adding that second step and as well as third step, you will get the physical memory. So that physical memory we are using to store the data. Okay, so this is a physical address calculation. So in order to calculate the physical address of code segment memory, I am taking this address, that is CS equals to 2500 and IP equals to 95F3H. So in this, first I am going to take the CS, that is the code segment register value, and to that I am going to multiply that 10. Okay, or you can shift this value by 4 times towards left. Then also you will get the value as this. That is 2500 into 10. You will get the value as 2530. So for that you have to add the corresponding offset register. The corresponding offset register for that code segment memory is IP. This you should add it. So that is 95F3H. Then you will get the value as this one, that is 2E5F3. So that is the physical address of code segment memory. This is one example what I am taking for the calculation of, for the physical address calculation of code segment memory. This is another example what you can take for the code segment memory physical address calculation. This is another example what you are taking in order to find out the logical address and offset address and physical address and lower range and upper range, right? So these are the slides in the different textbook. You can have the different problems. So depends on that you can go through the physical address memory calculation, right? So this is the physical memory calculation what you are taking for the 8086. So with this, so we have completed that memory segmentation and its physical memory calculation. In the next lecture, we will study about the pin configuration of 8086. So thank you.